All right, guys, today we're going to look at a couple of word problems dealing with geometric sequences. This is going to be pretty awesome. All right, so first we're going to look at money because everybody likes money. Okay, and we'll talk about money and we'll talk about putting money in the bank and getting some interest. All right, and we'll talk about exactly how to figure out how much money you're going to have in a certain amount of time. All right, and then we'll look at one other word problem, hopefully dealing with something else that goes geometrically, like rabbits. Rabbits, yeah, everybody likes rabbits, right? Okay, pull a rabbit out of a hat, everybody's happy. So we'll look at rabbits. All right, so here we go. We're going to suppose we're investing $1,000 in the bank. We leave the money there for 3 years. Each year we get 5% interest per annum. Now, per annum is often written PA. Okay, and what that means is that's the overall percentage for the year. All right, that'll become important later because they always give you the percent per annum. But sometimes they'll ask you, or they'll say that they're going to give you interest more often. But the per annum rate is still whatever they tell you. All right, so the question is, how much money do you have in the bank after 3 years? Now, we could do this, of course, in the obvious way. We could just say, okay, well, let's start with $1,000, and then I need to get 5%. And so I'm going to take my $1,000 and multiply by 0.05, which would be 50, and then I'll add that onto the 1,000, meaning that I now have $1,050. Okay, so then we could go on to the second year. We can do the same thing. So we're going to take our 1,050 and we're going to multiply by 0.05, and we're going to get 52.5, which then we're going to add to the 1,050, and we'll now have 1102.5. So now we have 1102.5. And so that was after 1 year, after 2 years. Now after the third year, I'm going to take the 1102.5, multiply it by 0.05, and then, of course, add the 1102.5 back on, because I'm going to keep that money. I'm just getting more interest. So 1157.63. Okay, now that would be the straight up easy way to do it. Of course, you know, that really only works if you're going to do a short number of years. If you're doing a long extended period, 20 years, 30 years, if you're saving for your daughter's future education, you don't even have a daughter yet, you're looking at, 30, 40, 50 years, and so you've got some time and you don't really want to have to do this every single time. So let's look and see if we can find a pattern. All right, well, am I adding the same thing every time? It looks like I'm adding 50 here. Did I add 50 here? No, so it's not arithmetic. Let's see if we can show that it's geometric. So we go from 150 divided by 1,000. So we go 1050 divided by 1,000. Oh, imagine that. It's 1.05. Now, it's 1.05 because when I went from the 1,000 to 150, I added 5%, but then I kept the 100% that I already had. Remember, 1 is the same thing as 100%. It means you're keeping everything that was there. So 1.05 represents the fact that you had 100% here plus another 5%. Let's try this again. Let's go 102.5 and divide by 1050, just so you can see Mr. Bywater isn't crazy. Oops, I totally did the wrong thing. 1102.5, there we go, divided by the 1050, and we get 105 again. All right, so let's clear that off. We do get 1.05. Now, because we have a constant ratio, we can write this in the form UN equals U1 R to the n minus 1. Okay? So if we put the numbers in, R is 1.05. U1 in this case is 1,000. R is 1.05. And then we've got n minus 1. Now, I'm going to make a couple of adjustments here because I want you to see a couple of things. This right here is not really 1.05. It's 1 plus the rate. Okay? Now, we're using a couple of different r's here, so maybe I'll use a big R for the rate, but usually you'll see it as a small r. So 1 plus the rate will be here. Okay, that's a 5% rate, which is 0.05. This is your principal, the starting amount. Okay, and then this is again the term number. Now you have to recognize that if this is the third year, What is n? N is 1, 2, 3. It's the fourth term because the first term is at the beginning after 0 years. And so that will be important later. Now, in the real world, you will often see this written in a different way. It'll be written un plus 1, and they'll add 1 to this n and add 1 to that n, making it u1 r to the n. Now, the reason why you'll see, actually, no, it won't even be written that way. I'm totally just kidding. It'll be u1 1 plus r to the n. Now, the reason why they do it this way sometimes is because then n actually represents the year number. So if you want the 5th year, then you're going to need 5. If you want the r, then is the rate, and then u1 is the principal, the starting amount. So yeah, anyway, that's what you'll usually see. This is what I will be writing over here because that's more consistent with what we have. The IB book writes something closer to this, but you know what? They don't give you that on an exam. And so it's much better to just get used to this because that equation is given to you, and you can then apply that to the given situation, understanding that the ratio is always going to be that 1.05, sorry, and that the year is just 1 off from the term number. Okay, so let's maybe look at a couple of other situations. We'll look at another example of this. All right, so let's go ahead and say you invest $5,000 for 20 years at 2% per annum. Okay, how much will you end up with? So this now should actually be a significantly more easy question, right? So let's take the UN, and we're going to say UN is equal to U1 R to the n minus 1. Okay, now U1 is the first term, which is the starting amount. So UN equals $5,000. Okay, times R. Now remember that the ratio is going to be 1 plus the rate, because we want to keep the $5,000 every year. That's the 100%, plus 2% more. And then it will be to the n minus 1 power, where n minus 1, of course, remember the 0 years is the first term. So if I want 20 years, then n is going to be 21. So I'm going to go U21 is equal to 5,000 times 1 plus 0.02 to the 21 minus 1 power. We can go ahead and plug that in here. And so we'll go 5,000 times 1 plus 0.02, so 1.02 to the power of 21 minus 1, which is 20. And enter 7,429. 73. Round it up, 74. All right, so that's how much money you would have after 20 years. Okay, now that's assuming that it's 2% per annum and it's given interest at the end of the year. But see, banks don't always give you interest at the end of the year. In fact, I have a bank account. In fact, I have a couple of them. One of them gives me interest every 3 months. That's quarterly. Okay, so let's go ahead and look at that situation. So my bank account will give me interest every quarter. Now, they don't give me 2% every quarter. They take that 2%. They still tell me what the percentage is per annum. But then they take that percent and they divide it into 4 pieces because they're giving it to me 4 times. Now, this actually works in my advantage because I get interest after 3 months. So in April, the very first day of April, I get some interest, which means I have money there that I wouldn't have had if I had to wait till the end of the year to get interest. So when the next time comes along, I'm already getting interest on that money. And so this actually works a little bit in my behalf. So let's go ahead and see what would happen. So we're going to write the same type of equation. Okay, it's still going to be a geometric sequence. I'm still starting with $5,000. But what's happening now is instead of getting 2% at the end of the year, I'm now getting 2%. But I'm not actually getting 2%, I'm getting a quarter of that because they're going to take that 2% and divide it into 4 pieces. And so there, that shows that each time I get interest, I'm getting a quarter of that 2%. But now I also have to take into account that I'm not just getting money at the end of the year. I'm not getting money once a year. I'm getting money 4 times a year because it's quarterly. And so I'm going to have to take this number and multiply by 4. So you might say, well, won't those cancel out? No, they won't, because this is division and that's an exponent. So they have nothing to do with each other other than the fact that this is showing that I get a part of that 4 times a year, and this is showing that I get 4 times, that it happens more often. And so when I put the 21 in, you'll notice, here, we'll go ahead and plug this into our super calculator here. So we'll go 5,000 times, and then I'll go 1 plus 0.02 divided by 4, right, to show that I'm not getting that full 2% every time I get interest, to the power of, now 21 minus 1 is 20, so I'll go 20 times 4. All right, so when I push enter, you'll notice it'll be very similar, but I got a little bit more because there's that little bit of interest that I'm getting money on each time. So 7,451 and 69 cents. Now, it's not a lot when you're looking at just $5,000, but if you're looking at $5 million, you're looking at several $1,000s extra that you're getting. Okay, so yeah, it is quite a big deal. All right, now I would like for you to try monthly on your own. I'm going to do it over here on the side, okay, but it's just going to all of a sudden appear in about 10 seconds. So you try it on your own and pause the video and then check and see if you did it right. Note that monthly means that you're going to take this rate and you're going to get it only a 1/12 of that at a time, but it's going to happen 12 times more often. All right, so go ahead, give it a try. All right, there you go. You can see that on this piece, I divided that rate by 12 so that I can get a little bit every month, and then it's going to happen every month instead of once a year. So I'm going to get it 12 times a year, so that's why I multiplied by the 12. And you can see on my calculator here, I actually show my equation, and let's see if we can, there, see I got 5,000 times 1 plus 0.02 divided by 12, and it's not going to let me show the exponent, but you get, oh, there it is. So divide by 12 times 20, because that was 21 minus 1 times 12, and that's how I got the answer. Now, I would like for you to try this one by yourself. Please note that 50,000 is not what I start with, it's what I'm ending with. Okay, so try this out by yourself, and then I'm going to show you how to do the rabbit one. All right, so here's the answer to this one. Note that 50,000 was the final amount, so I put it in for UN, and then I put in U1 is the unknown. That's what I'm starting with, and so that's what I'm solving for. And then I got 1 plus 0.05. That's the rate. 11 because 10 years. Remember, 10 years is the 11th term. And so here on my calculator, I can show you what I did. I divided the 50,000 by the 1.05 to the 10th, and there you go. The answer is $30,695.66. And then at the end of 10 years, I would have $50,000. Pretty cool, huh? All right, well, let's talk through the rabbit. Last one, let's look at some rabbits, because everybody loves rabbits. I decided to run a rabbit farm. I have 50 rabbits. The population grows at 7% per week. How many will I have in 15 weeks? Now, this should be a fairly simple question now that we've looked at the difficult stuff with the money and the compounding and all that fun stuff. So let's go ahead and try this out. So I start with 50 rabbits. So U1 is 50. The population grows at 7% per week. That means that the ratio is going to be, I'm going to keep all the rabbits I have plus 7%, so 1.07, and then 15 weeks. So remember, n is 1 greater than the number of weeks, because the 0 week is actually n1, 50. So 1 week I would have more already, so n is going to be 16. So we can go ahead and plug it straight into our equation where un equals u1 r to the n minus 1. And so we'll go u16, which would be the 15th week, equals 50 times r, which is 1.07, to the 16 minus 1 power. Easy peasy. Here we go. 50 times 1.07 to the power of 15, because it's going to be 16 minus 1, and enter. 137.9, so about 138 rabbits. That's a lot of rabbits. Now you know why they say that when you have lots of babies or something multiplies really fast, you're multiplying like rabbits. All right, that's it. Let me just remind you, remember when you're compounding, you're going to divide by the number of times in a year that it's compounded and multiply the exponent by that number to show that that's going to happen that many more times. Okay, and that again is called compounding. All right, and the other thing to remember, of course, is that the n will always be 1 greater than the number of years because year 0 is in 1, right? So there you go. I hope that's helpful, and I hope that you'll be able to do some problems with that now. Good luck. Ciao.